In this video, I'd like to review using National Instruments Multisim to simulate a simple circuit with, say, two resistors in series and measure the voltage and the current voltage across a resistor or current through a resistor. We're going to start by, in the search, typing Multisim, and there I'm finding NI Multisim. That's installed on this machine and in the lab I'm in. And that's going to open up, and then I'm going to use this to simulate a circuit. So I want first sort of a DC power supply, which I'll often just call a battery. So I started here under sources, place source, I choose power source, I choose DC and say okay. And then the way it's set up right now, this automatically opens back up, and I want a ground. So that's another feature from the same area I want. And then it dragged that over and it opens up again. And I can either close it or I can switch my group. So I can switch over to the basic, and then I want a resistor. Or I could say close it and then come back over here to place basic and get resistors. So either way, let me just grab two resistors just randomly, 2.25, and then maybe a 3.16, just two resistors, doesn't matter. Okay, and then I'm going to close that again. I want a voltmeter and ammeter when I'm done, but so I could switch over to where they are by changing the group, or I could, and they are under indicators, or I could close it and then start again. So let's just drag them out while we're here. So I'm going to place indicator, and I want a voltmeter. And I can place the voltmeter across either R1 or R2, depending on which one I'm interested in. So if I keep the resistors as they are, maybe I'll do R1. So maybe I'll choose to measure the voltage across R1. So I'll want, so there's a horizontal, which is the points where you can access the voltmeter are horizontal or vertical, and then there's reverse. So do you encounter the plus and then the minus, or do you encounter the minus and then the plus? So the way I'm going around with this one, I'm going to go from the large end of the battery into R1, and so I'm going to encounter the high voltage first. So I want the voltmeter H rather than HR. And then I want an ammeter, and I'm going to sort of come at some point, sort of turn a corner and start coming down. And I want my ammeter then to be a vertical ammeter, but I am going to encounter coming from the top, the plus and then the minus. So I want it to be V rather than VR. And if you had V and you really should have had VR, or you really wanted V, if you got the wrong one, then you're just going to get like a negative answer. It's not a huge deal, but okay. So those are my items that I want. Now I'm going to close it. Now I'm going to start connecting the circuit. Let's say I want the R2 to be pointing down, then I might right click and rotate it clockwise. And so I'm going to come out of the battery and I'm going to go through this resistor horizontally, and then sort of turn a corner and go through this one. Will be vertically oriented. Not that it matters. It matters how it's connected and not, it matters how the wires are connected and not the sort of horizontal or vertical orientation of the resistors. That really doesn't matter. So we're going to come out of the battery and we're going to go to resistor 1. So again, let me do that. I'm just going to put my mouse near the top of the battery, and I get this I have an arrowhead, and then it turns into this sort of crosshairs with a dot in the middle, and then I can drag from one end to the other. Okay, then I can come over here to the other side of the resistor and drag over to the top of this resistor. Now, if I'm interested in the voltage across this R1, let me make a little more room for myself. So I'm going to sort of highlight all of these things, but not the voltmeter, and I'm just arrowing down. It gives me a little bit of room, okay, because this R1 was interfering with this this resistance of the voltmeter that I'm showing here, 10 mega ohms. And when you use a voltmeter, you connect it in parallel. So in parallel means there's a connection on one side between the resistor and the thing that's it's in parallel with, in this case, the voltmeter. And there's a connection on the other side. So there's a wire connection on this side, there's a wire connection on that side. And that wire connection is going to be connected to other things, that doesn't matter. But that there's a path from, there's a wire, there's a path from one side of the voltmeter to one side of the resistor, and on the other side, there's also another path of voltmeter to resistor. Okay. Now the current, now the idea of meters is that like they're ideal, and it's like they're not there. So the charges come out of the 12 volt battery and go through R1, and then they go through R2, and then I want the ammeter to be in series. I want them to have to go through the ammeter. So the ammeter should be in series here. I could also put the ammeter here. I could put the ammeter here. All those places are in series with these two resistors. The current comes out of here. It has to go through R1, it has to go through R2, it has to go through the ammeter. So those are all places that see the current. So I could put the ammeter here, I could put it here, I could put it here, I could put it here. All those places are seeing the same current. Then after I've, in this case, the way I've drawn it here, out of the ammeter, I want to return to the other side of the battery. I want to make a path. And then I want when we have a battery, it just says that one side of the battery is 12 volts higher than the other side of the battery. But we want to sort of make it clear in our simulation, 12 volts higher than what? And so we use a ground, and the ground says that's where the voltage is 0, gives us a defining point. And so it says that okay, so this side, this is 0 volts, and now we're 12 volts higher, but higher than what? We're 12 volts higher than 0, so we're 12 volts up here. Okay, so now I have a circuit ready to simulate. I like to sometimes change the colors of some of the wires, and that helps me see if I've got good connections. It also, I'll often color what's connected to ground. I'll often make that black, and that will remind me sort of all these things are grounded. So the bottom of the battery is 0 volts, is grounded. The bottom of the ammeter is connected to ground. It sees 0 volts. Okay. So there we go. We have the 12 volt battery sending charges out through R1 and R2, and then through the ammeter to measure the current. And the voltmeter is in parallel with the R1, so it's measuring that voltage. The voltage has to be used up between R1 and R2, but R2, being the bigger resistor, takes more of our energy, more of our voltage. So we're expecting to see a voltage here less than half, less than 6. And then we're going to turn this on, and we see here we're getting a voltage of about 5. Of the 12, 5 of it's here, so we imagine that there must be the other 7 here. And then overall, both resistors are seeing a current of 2.21 milliamps. Okay. Then if I wanted to change the voltage, so that was the setup for 12 volts. Let's say I wanted to see it for 6 volts. So then I can right click on this battery. I've stopped the simulation by hitting this red square, the stop button. And now I'm going to change this 12 volts to 6 volts by going right clicking and choosing properties. And then here's my voltage. I can change that to 6 and say okay. And note that it didn't change these numbers. It won't change these numbers until I run the simulation again. So it's easy to sort of get a wrong picture. I could do a screen capture and, this doesn't make any sense until I run it again. So just a note that sometimes you can get a picture of a circuit where the voltages aren't right if you didn't rerun it. Okay, so let me rerun it. There we go. And now it is, I overall my voltage is half. So now I expect my voltage here to be half of what it was before. So it was around 5 before. Now it's around 2.5, which is half of the 5. So that makes sense because it's a resistor. So we expect the voltage split to be between the two to be the same relative split, but if the overall voltage is half, then we expect each of these individual voltages to be half, and we expect the current to be half, and that is also the case. It was two something milliamps now, and it's 1 point something milliamps now. All right, that's all I wanted to show you here, so thank you for your attention.